Hello. In this video, I continue the Introduction to Coding Web Games using HTML, CSS, and JavaScript series with part 5. In the previous video, we learned a bit about objects, dynamic functions, and animation. In this video, we will learn how to draw images onto our canvas and how to utilize sprite sheets. Before we delve into that, however, I'd like to show you a few more details about dynamic functions in our canvas element. All code and images in this video are available for download at the link provided below. Let's begin. If you can recall, the state we left our program in was a blue background with a 500 by 500 yellow canvas on it and a pink to red gradient ball that slowly fell down until it reached the bottom of our canvas and then stopped. And that was cool. So we're going to set aside the animation for just a moment to focus on drawing images. But before we do that, I promised I would say something about drawing lines because that's a pretty fundamental thing to know how to do when you're drawing on your canvas. So, in the render function, we're going to draw a line, and we're doing it in the render function so that it redraws the same line over and over and over, and it'll look like just one line, but it's actually a bunch of different ones, but that's not the point. Just like always, you will want to start or begin your path. So you say context.beginPath. Then you're going to want to tell your stylus or whatever to move to a certain spot on your canvas. So you say context.move to, capital T, and it's going to take two parameters. It needs an X and a Y coordinate. And for simplicity's sake, I just said go to the top left-hand corner of our canvas, which is 0, 0. Now the next function you're going to need is one called context.line_to, as in draw a line to this spot, and it's a lowercase l. And it takes an X and a Y coordinate, but this is where you want your line to end. And again, for simplicity's sake, I just chose the bottom right-hand corner of the canvas, which is 500, 500. Pardon me. Next, you're going to want to tell it what color. Oh, I'm actually sorry. Yes, once you've defined your line, you need to close your path. Context.closePath. Now, it's going to default to black if I don't tell it what color to draw my line. So I like to tell it by changing the stroke style. And you'll see me mess up here and write stroke color. And I'll set that equal to silver. But just imagine that instead of color, I've written style. And then later I will come back and I will fix it when it doesn't work and I realize that I've made a mistake. So context.stroke_style equals silver. And next, context.line_width, because I want to be able to see my line. It will default to a line width of 1, which makes it very hard to see. So I'm going to set that to 10, make it a nice thick 10 pixel line. Once all that is set, I can now draw the line by calling context.stroke, as in the stroke of a pen. So when I refresh, you see I have a line from one corner to the next, and this is where I'm realizing that it's black and that I have put color here instead of style. So now I am fixing it to context.stroke_style equals silver. And there you have it. Okay, so it's very simple. You can draw lines all over. You can draw entire pictures out of the lines. You can even draw curvy lines. I suggest you explore that. But for now, we don't need it anymore, so let's go ahead and get rid of it. I don't really need it at all. And I want to show you a bit more about why we made our draw circle and draw rectangle functions dynamic. I've only drawn one at a time, but what if I wanted to draw multiple circles all at the same time? So I'm going to try to draw 3 at the same time. So let's make a for loop. And this for loop is going to be a bit different than any we've done before, because inside of it, we're going to create a variable called I for index and set it equal to 0. Then we're going to check in our for loop if that I is less than 3, which when we start, yes, it'll be 0. Don't forget your semicolons. These are very important. Now, every time the loop runs, it's going to increment the I up 1. So that's why we do I++. So now, it takes an I and it sets it to 0. Then it checks to see if it's less than 3, which it will be. And it does something within this loop. Then it increments, after it's done, it increments the I up 1 and checks again to see to make sure that that I is less than 3, which it will be because it'll be 1. Then it runs whatever's in the loop, then it does that all the way up until 3 is equal to 3, because 3 is not less than 3. That breaks the for loop and continues on with your code. So inside the for loop, let's put our make circle function so we can make 3 circles when that loop runs 3 times. But if we leave the x and the y the same, then we're just going to draw 3 circles and one on top of each other. So we need to make let's make the x coordinate a little more dynamic. And one great way to do that is to multiply it by some variable that you know is going to change every time you run the loop, which is the I. The I is first going to be 0, and then every time the loop runs, it's going to go up by 1. So first time it runs, it'll be 150 times 0. Second time, it'll be 150 times 1, making the x different for every circle we draw, which in this case, we should have 3 x's lined up along the same y-axis, but different x-axis starting at 0, just like that. And they all 3 fall because they all 3 have the same update function. If you want to move it over, you can say I plus 1. Now instead of the first time the loop running it being a 0, it'll be a 1. So that means everything gets moved over. And there you have it. That makes it a little more dynamic. Now you know why you need to not static code all of your make circles and stuff like that. Okay. So moving on to the nitty-gritty, let's start drawing images on our canvas. To do that, we're going to need to make quite a few changes. One of the first things we're going to need to do is we're going to need to define an image object just like we defined a circle object. So we say let image object equal open and close curly braces, semicolon, and then within those curly braces, again, we're going to have to give it a bunch of parameters just like before. And as usual, it's going to need an x and a y, and since this is going to be a rectangle, we give it a width and a height. And again, when you're in attributes, it's the attribute name. You know, here's a good chance I can talk to you about what this is called. The x, that would actually be the key, and then the 0, that's the value. So these are actually key value pairs inside your object. Your object it holds a bunch of key value pairs. So just so you know that the x is the key, then it goes colon, and then there's the value of 0. So our next key would be source x. Now, images need 2 x's, 2 y's, 2 widths, and 2 heights. One is for the object in relation to the canvas. Where is the x on the canvas? Where is the x on the y? How big do you want it on the canvas, width and height wise? The other set of x, y coordinates and width and height, which we're calling source x, source y, source width, and source height, are in relation to the image itself. Where on the image do you want me to start drawing? Where on the image do you want the y to be, the x and the y? Where on the image, or how big on the image do you want it to be? This will all become a little bit clearer once we start really drawing. But just so you know, x, y, width, height, that's in relation to the canvas. Source x, y, source width, and source height, that's in relation to the image itself. We're going to give it an update function because later on we're going to want to come back in here and do something to this update function, but for now we don't really have anything to put in there. We just want it to be a static, just sit there picture. So we're going to leave that empty. We still want to put it in there, but just leave it empty and move on to giving it a draw function. So draw colon space function, open close parentheses, open close curly braces. This one doesn't need the comma after it because, again, it's the last one we're going to put in there, so it doesn't need to be separated. In this draw function, we're going to call a very specific function called context.drawImage. Just like you see it here, capital I, parentheses, all that. Open up these parentheses, and on this first line, we need to pass an image. So I write this dot image, and then I suddenly realize that I have forgot to set the image attribute. So up here, underneath source height, I give it image, but since I don't have an image to pass to it right now, even a fake one, just leave it undefined and write undefined in there, and don't forget your comma. So now it makes sense to put this dot image as the first thing. So a draw image function, the first thing you need to pass it is the image. Then, comma, this dot source width, and comma, then this dot source height. Actually, I'm wrong. You need to pass it this dot source x and y before the width and the height. So you see me fix it in here now. Just make sure you get it all in the right order and it'll work. Once I'm done writing it out here, it is in the right order. It will work. While I'm writing it, I flubbed up a second. So first you send the source x, source y, source width, and source height, and that's where you want this picture to be drawn in relation to your image itself, the source. Then you need to send it the x, the y, the width, and the height that you want in relation to the canvas, where and how big you want it on the canvas. And again, this will all become a lot more clear once you see me draw an actual image. You'll be like, oh yeah. Okay, so that's the draw image function. So every time an image object is made, it gets that function, and every time that it is updated and drawn, it draws an image. So let's do a make image function. Just like we have a make circle function, we're going to do a make image function so that we can make an image anytime we want just by calling this. And we're going to have to pass it all of those coordinates. I mean, not coordinates, excuse me. All of the, well, parameters. All of these parameters. So we're going to need an x, we're going to need a y, we're going to need a width, we're going to need a height. That's for the canvas. And then a source x, source y, source width, and source height. That's for the image itself. And then, of course, we need the image. So within make image, just as in make circle, first thing you're going to do is you're going to create the object by saying let temp image equal object.create. And then, as you probably already guessed, you're going to send it the image object that we defined right up here. Instead, like we sent the circle object, so now we're sending it the image object. So now that temp image has all those parameters, and we can start changing them. We can start setting them. And we're setting them to everything that has been passed to us in the function. So instead of typing everything out, you're going to see me copy paste the proper amount of times and then just go in and change everything like this. Just a shortcut so y'all don't have to watch a super duper long video. It's all self-explanatory. I'm just taking the image attribute and setting it to whatever has been passed up there, like I said before. So source width, source height, and then image. I am going to do something different at the end here. For the first time, I'm going to return something after I am done in a function, because I'm going to want to use this image for something later. Before I do that, do not forget to push it onto your sprite array so that it will actually get drawn, because everything that's in the sprite array is what we're drawing. So you say sprite array dot push temp image. Now, return. The very last thing you're going to do is return temp image. So every time I call make image, I'm also going to return the image I just made to whatever variable I'm setting that into. And then I think I start to try to call make image before I realize that I don't have an image to send to it. I've created the image object and I've created a way to make image, but I need an actual image. So bear with me here while I start to make an image. And then I realized, wait a toot, I don't have an image to send in this function. So now let me show you how to instantiate an image, how to create an image. It's another way of making an object, except that this object has already been defined, and it's already a class all its own. You don't have to define it. All you have to do is invoke it. So you say let, and we're going to call it sprite sheet, since we're going to be using a sprite sheet. Let sprite sheet equal new, all lowercase, image, capital I, with parentheses and a semicolon. Now what you've done is you've instantiated an image object and you've put it into sprite sheet. Sprite sheet is now an image object, and just like our objects, the ones that are already defined, they have attributes as well, like a source. So we can set the sprite sheet dot source, which is just src, equal to something, and we're going to set it equal to sprite sheet dot png. Now this is again me realizing that I have yet to show you spritesheet.png, the image we're going to be drawing. So here is where I get it from. You will be able to get it at the link below this video, and in the GitHub repository it'll be available there. And then what you do is you take it and you put it, copy it or download it into your root directory. Here I'm just going to paste it into my root directory. But make sure you grab spritesheet.png from the link below and you copy it or download it into your root directory so that this line makes sense. Spritesheet.source now does indeed equal spritesheet.png because it is in my root directory. Okay, so the next thing I want to do with spritesheet is I want to add an event listener. And I'll explain a little bit more about event listeners now. It's listening for something specific to happen to that image. So you type spritesheet.add event listener, capital E, capital L, parentheses, and in the quotation marks, it's going to ask me what am I listening for? I'm listening for that image to load. When that image is done loading, I want it to do something. And what I want it to do is I want it to call load handler. And the false, just know for now that you need to put the false in there. It's nothing that we need to worry about. Just put false. So make sure you write it exactly as I have it there. And then we're going to come down here and we're going to say assets to load dot push. And again, this is me realizing that I haven't quite made assets to load the array yet. I'm trying to push sprite sheet, the image, into an array that doesn't exist yet, but I'm going to make it here in a moment as soon as I realize that I don't have it. So just bear with me and keep following along, keep typing what I'm typing, and when we get to when we're ready to test, it'll work as long as you keep following with me. So now we have to actually make that function load handler. We told the sprite sheet to call it when it's done loading, and within load handler we're going to say assets loaded plus plus. And again, I haven't made assets loaded yet. And I think right about now is when I realize, oh yeah, I haven't made these variables. So up here at the top, underneath sprite array, say let assets loaded equals 0. That's a number that we're going to increment up by 1. Then we need an array to hold all of these images. So you say let assets to load equal an empty array, just like sprite array. So now that we have actually created those, it makes sense down here when we're using them. Apologies for getting that backwards. So in load handler, every time an asset finishes loading, it calls load handler and it increments assets loaded up by 1. So that means every time a picture loads or an image loads, assets loaded goes up by 1. And if assets, and you see me checking it here with an if statement, if assets loaded is equal, give it the triple equal sign because that means really equal to. So if assets loaded is equal to assets to load dot length, meaning the number of assets in the array, what this means is if all of the images are loaded. In shorthand, you can just say if all of the images are loaded, Then I want you to call the update function and get this animation started. So now that we're calling the update function up here, we don't actually have to call it down here. We were calling it once the window was done loading, excuse me. Now we're going to call update when all the images that we have in our program are done loading. Right now we only have the one image, so it's going to be very quick. It'll just load the one image and call load handler, and then assets loaded will be equal to assets to load.length, so it will call update. Okay, now that we have taken care of that, now that we have an image to actually send in our make image function, we can call it. I'm going to type out manually everything that we need, all the parameters that we're going to need to send so that you can see. We're going to need to send an X, a Y, a width, a height. We're going to need to send a source X. We're going to need to send a source Y, a source width, a source height, and then again that image. And I will replace these numbers one by one while explaining exactly what they correspond to, so that you can get just a little bit better grasp as to what source width and source X and all that is. So yeah, finally I have an image now, so I can send the sprite sheet image. For the X and the Y, the width and the height, since I'm going to be making I'm just going to draw the background. I'm just going to make it the same width as my canvas. It's going to start up in the top left corner, and it's going to be the same width and the same height as my canvas. The source X and the source Y and the source width and all that are going to be similar because I'm going to use the entire picture, and this picture is very similar in size to my canvas pixel wise. So to keep things simple, on this canvas, upper left is still 0, or on this picture, excuse me, upper left is still 0, 0, and bottom right is still 500, but one is in relation to the picture and one is in relation to the canvas. So okay. So for the X and the Y, the width and the height, since I want it to be, I wanted to cover the entire canvas, just like the clear rect function from the last video, I'm going to start it at 0, 0, the very upper left hand corner. And I'm going to give it the width of canvas.width, as in make this image span the entire width of the canvas. Same with the height. For source X and source Y, again, it is still 0, 0, but I need you to understand that it's a different 0, 0. It is now, I'm talking about the 0, 0 that is the corner of my image up here, not my canvas. The source width and source height, even though they're both 500, 500, I am talking about the width and height of my image, not my canvas. Oh yeah, to be honest, I think the image is only 450 pixels tall. I don't think it's a full 500. So now that you can delineate. And there you have it. We've done it correctly. We've loaded our image, we created the image object, and we told it to make it the exact same size as our canvas. Except there's only one problem, is it does draw the entire image, and you can see all the little sprites up here that I don't want you to see, all the little images. Plus, it's not exactly covering our entire canvas. On the right, you can see the little yellow line. So this is a good opportunity to show you about source X and source Y. If I tell the source Y to come down by 50, so I'm adding 50 to the source Y because that means I'm coming down, then that will start it'll grab the picture and it'll start at 50, which will be well below these images. It'll start there a lot where the space starts, basically. So I'm going to need to add 50 to my source Y so that I start drawing the picture lower in relation to my to the image, not the canvas. It's going to draw it at the same place on the canvas because I haven't changed that. And there you have it. Now it starts the drawing where space starts. But as you can see, now it's a bit short at the bottom. So you can kind of fuss with it and tell its source height to come in by about 50. So we'll say 400. And that will have the effect of stretching the picture on our canvas, just like that. This is one of those parts of the code that is just really fun to play around with and see what you can do. You see that yellow line? I'm going to play around with the numbers, adding 1 to the width and the height so that it gets a little wider and a little taller, and maybe hopefully that'll get rid of the but now this is in relation to my canvas. I'm not changing how I'm grabbing the picture from the sprite sheet. What I'm changing now is how big I'm drawing it on my canvas. So I've gotten rid of the line on the right, but there's still one up top. So in relation to my canvas, I can change the Y coordinate and tell it to bring it up a little bit, which, if you recall, means negative. Well, that didn't work. When in doubt, double down. Okay, well, it got rid of that, but then look, showed the bottom line. And that can be fixed by changing the height, again, in relation to the canvas, not the picture. There you go. Now I have only the space and earth image from my picture being drawn across my entire canvas, and it is leaving out any other pictures I don't want because I have specified with the source X, source Y, source width, and source height. You know what? Let's do something to this CSS file. Go to your CSS file, put a body tag in there, so BODY, and then open close parentheses, and give it these attributes. Give it position, relative. We don't mess with the CSS that often, but I'm tired of having my canvas on the very far left of my screen. Oh, apparently, I'm sorry, it's position absolute. I thought it was relative, my bad. So you give it position, colon, absolute, semicolon, width, colon, 100%, semicolon. Does this seem familiar? Your CSS has key value pairs as well. Text dash align, set that to center, and what this will do is it will put our canvas in the middle of our screen. Okay, we're not quite done yet. Now that we have a nice background, because we've learned how to snag just a portion of our sprite sheet, let's snag a smaller portion. I'm going to say an even smaller portion, and let's just get one of these little aliens. So to do that, I need to make another image. And I need to change its relation. I need to change its source information and where I want to draw it. So let's decide where I want to draw it. I think I decided on just giving it canvas.width divided by 2 and canvas.height divided by 2 so that I could show you that these are drawn the same way as rectangles from the upper left-hand corner. So that when I do canvas.width divided by 2 and canvas.height divided by 2, you'll see that it won't put it in the center. It'll actually just put its upper left-hand corner in the center, and then the rest of it will be, to the bottom right of it. Let's give it a width of 50 and a height of 50. And again, in relation to the canvas. Now we have to change its relation to the image. On the image itself, its x-coordinate is actually pulled in by 50. So this is 0, this is 50. But its y-coordinate is still 0. It's still the top. Or it is 0. So its x over here has to be 50, and its y-coordinate has to be 0. And it is not 500 pixels by 400 pixels. It is 50 pixels by 50 pixels. because every one of those little tiny squares, again, is 50 pixels by 50 pixels up top. Oop, oop. So now, when I draw this picture, you know what? Let's not make it 50 by 50. Let's show you that in relation to the canvas, I want to make it 150 pixels by 150 pixels. Whoa! So even though it's a small picture, I can draw it as big as I want on my canvas. That's too big though. Let's go down. Let's do 60. It's not 50, but it's still kind of small. So there it is. Now it's only 60 by 60. But you'll see it's the same picture. In relation to the sprite sheet, that didn't change, so you still only see the little alien. So what I'm going to do now is I'm going to go just a smidge further, and I'm going to show you how you can animate this guy by changing its state. Up here you have an update function, but for aliens, let's give them their own little update function. And in order to do that, we have to give it a make alien function, which isn't hard. Right here above load handler, we'll just put function make alien, open close parentheses, open close curly braces, and within here you're just going to grab this make image, because this is your alien image here. But now that we've done this, do you recall where once we make the alien image, or once we do make image, we return it for the first time? Oh, I went the wrong way. The reason I wanted to return it is exactly for this reason here. There it is. See, you return the temp image once you're done making it. It's because up here I want to set it into a variable. I want to say let alien, or you know what, let temp alien, because let's not stray. Let temp alien equal make image. So now it's going to make the image using all the stuff that I've just sent it, but then it's going to return that image and put it into temp alien. So then I can go temp alien, and I can change some of it, like the update function. I can say temp alien equal dot update equals function, open close parentheses, open close curly braces. And now within here, if you can follow my logic, that'd be great. I'm going to try to explain it great. We're going to check to see that if this dot state, and it doesn't have a state yet, so obviously it's okay. So we're going to check if this dot state is not equal to 0, and since it doesn't exist, it's not going to be equal to 0. So that'll be true. This dot state will not be equal to 0 because for now it doesn't exist. But then you say this dot state is equal to, okay, so I put 1, it's supposed to say 0. For now, just put the 0. Do not put 1 there. Put this dot state equals 0. Then you put this dot source x plus equals 50. So what you're doing is you're taking this image, and every time you update it, you're moving its source x, which right now is at 50, and you're adding 50 to it, making it 100. So it's going to start showing you something completely different. It's going to move it to the right 50. And then also something we haven't really done done before is this else statement. If the first statement's not true, you want to do something else, which is just the reverse. So copy paste and then just reverse everything. So now every time the update is called, it's going to change the state. But if you recall, this update will be called about 1,000 times a second. So we're going to do just one more thing here, or a few more things to be honest. And we're going to say temp alien.count is equal to 0. So now your alien has a count. And down here underneath your else, write this dot count plus plus. Every time it's updated, this dot count is going to go up by 1. Which makes it a problem if you run your program too long. So underneath that, write if this dot count is equal to, and triple equal, make sure it's real equal, is triple equal to 100. You want to do something, and you want to say that this dot count is now equal to 0. So that's just going to reset it. Every time it hits 100, it'll put it back to a 0. It'll just keep cycling through that so that you don't get some ridiculously large number like a bajillion. Okay, so now this if-else statement, the whole thing needs to go in its own if-else statement, which is, it'll type just what I'm going to type here. I'm going to type if this dot count per %10, and what that means is remainder. It means remainder 10 triple equal to 0, and then enclose the entire if-else statement, but only the if-else statement, not this dot count. Leave that out. But enclose that entire if-else statement in your curly braces, and then I format. So what that says is if this count divided by 10 has a remainder of 0, that only happens every 10 frames. So what you've just done is you've taken it, now instead of happening 100 or 1,000 times a second, it'll only happen 100 times a second. Okay. So what we've actually done, if we've done this correctly, is every time it updates, it'll move the picture 500, the source width 500, or source X, excuse me, 500 to the right, and it'll show you the picture immediately to its right. And then the next frame, or the next 10 frames, it'll move it back 50, and it'll look like it is flipping between those two pictures. But now, first of all, I believe I've gotten something wrong here. Oh yeah, first of all, you have to actually call make alien. That is always my biggest bane, is that I forget to call the function. So you actually have to call make alien. But my logic where I put 0, this dot state equals 0, and this dot state is equal to 1 is incorrect. So all it's going to do is it's going to keep moving it to the right. And as you see there, and I'll replay it here in a second, instead of moving it back and forth, it just kind of keeps moving it to the right, and you see all the images instead of it flip-flopping back and forth. So I think real hard on this for a second, and then it takes me a while before I realize that where it says this dot state equals 1, it needs to say this dot state equals 0, and where below that it needs to say this dot state equals 1, and that will successfully flip-flop it back and forth. That will add 50 to the source X, meaning it starts showing you a completely different part of the sprite sheet, and then on the next 10 frames it'll subtract 50 from the source X, and it'll go back to the original image, and it should give it the effect of the little alien flip-flopping its little flappers around, because one image has the flip-flops up and one of them has them down, just like that. Yay! So now you have a little alien flip-flopping. Congratulations on completing part 5 of this series. We've really come a long way in just 5 videos. As per usual, I highly recommend that you experiment with the code we've just written and make it your own. In the next video, we'll be adding a collision test to our animated objects. I hope you'll join me.